All right, so what do I need to do so I can graph this on my paper? Hey guys, we're not going to do food right now, so put all the food away. Yeah, we're going to do second table. Can somebody tell me, so this graph, if you look at these, they do not have a vertex because a vertex is where the graph switches from increasing to decreasing. It would be like the very middle of the graph, and these don't have that. They do, however, have what we will call a locator point, and the locator point is where the graph starts. So this one has a locator point of 0, 0, and you find the locator point exactly the same way you find the vertex. So what would the locator point be for this equation? Okay, so locator point is -5, -7, and the benefit of knowing where that point is we know where to look on the table to find other points that we can actually graph, okay? So if you hit second table, then -5, -7 is like the very first point we can get. You can see all the points to the left of that give you an error message because they're not actually defined. You can't graph them, okay? So I've got -5, -7, -4, -8. And then I'm gonna skip a few because they're decimals. And then I have -1, -9. And then skip some because they're decimals, and then 4, -10. What transformations do we have? What are the transformations? We've got a negative in the front. Reflect over x. What else do we have? Left 5. And then what's the last one? Down 7. Okay. All right, we also want to be able to find the domain and the range. This is the very first time in this class this semester that we've had a domain that is not -infinity to infinity. So if we are looking at how far left the graph goes, what do you see? How far left does it go? -5. And then it has all the values and then a right arrow. So what are we going to put? Positive infinity. And positive infinity is always going to get a parenthesis because we can't actually say, oh, that's where infinity is. What about the -5? Does that get a parenthesis or a bracket? A bracket. Okay. And then for range, we're going to say from the bottom to the top. So how far down does the graph go? -infinity because we have an arrow going down. And then what's the highest the graph can go? I heard negative. We're going to use y value because we're doing up and down. So -7. All right, so we've got a parenthesis around the -infinity. What do we have around the -7? A bracket. Okay. If we put our little stick figure right here, what is he doing? He's going down, he's decreasing. What was the x value right here? -5. What is the x value of a right arrow? You were right, positive infinity, because it was a right arrow instead of a down arrow. So we're going to say for increasing, what do we say? None, okay. And then for decreasing, we say -5 to infinity, and I always use parentheses because, why do I always use parentheses for increasing and decreasing? Yeah, if I look at that point all by itself, I can't say that point slanted down. It's just a point, it's a dot. Okay, so we have locator point, domain, range, increasing, decreasing. What are some other things we typically find? Max and min. So do you see something that looks like a mountaintop or something that looks like a valley? The maximum, it has to look like this. Maximums have to go up and come down, and minimums have to go down and come up. So we're going to say none. Yeah. So these graphs, no matter where they are, they never have a max or a min. And we haven't really seen that before either. Okay. So locator point, domain range, increase, decrease, max, min, transformations. What else can we find? X and Y intercepts. What do we see about the X intercept? There are none. It never crosses the x-axis. Okay. What do we do to find the y-intercept? Okay, so in my calculator, I do second trace, option number 1, plug in 0, and my y-intercept is negative 9.236. Okay. We also want to see if the graph is continuous. So if I put my finger where it starts and then trace the whole graph, do I ever have to pick up my finger? No. So I'm going to say this is continuous. Okay. And then last, we want to see about the end behavior. So what do we typically check when we do end behavior? So what do we check for end behavior? We always do two things, right? What are the two things we do? Yeah, so we're going to look for the left side of the graph and the right side of the graph, okay? So as x goes to the left forever, does x go to the left forever? No, so I'm going to say y equals undefined because x does not go to the left forever. It stops. So we can't say what happens when you plug in a very big negative number, because if you plug in a very big number, what happens up here? If I plug in like negative 1,000,000, what's negative 1,000,000 plus 5? Plus 5 would be like negative 999,999, or 995. That would be a very big negative number underneath the square root. And what happens when we square root negative numbers? They're imaginary. We get an error message, right? Okay. So we're going to say as x goes left forever, the y value is undefined. You plug it in, you get the square root of a big negative number, and you can't do that. Okay. As we look to the right of the graph, so as x goes right forever, is the arrow going up or is the arrow going down? Down. So I'm going to say y goes to positive or negative infinity. Negative infinity because the arrow is going down. So as we go to the left, the y value is undefined. As we go to the right, the arrow goes down. Okay, well, let's try the next one. None of that was really new necessarily. The answers might have just been a little different from what we're used to, okay? But everything we found was fairly typical. So we're going to go ahead and graph the next one. We've got 1/2 x minus 1 cubed. So I should hear lots of typing because you guys are all typing this one in. What is the locator point on this one? Yeah, the locator point is +1, +5. So when we look at the table, we're going to be very interested in what's happening around +1. So again, we call this a locator point, not a vertex, because technically a vertex is where you switch from increasing to decreasing or switch from decreasing to increasing. And so here we're increasing, leveling off, and then increasing again. So that's why we don't call it a vertex. We call it a locator point. So if I do second graph and look at my points, I see 1, 5 is right there in the middle. And then I don't feel like graphing decimals, so I'm going to go ahead and go to the next one. So I've got -1, 1, and I've got 3, 9. So -1, 1, and 3, 9. So for the positive x values, I can't graph anymore. They're going to be off the screen, but I could look and see if I can do some more negative values. Nope, they got real negative real fast. Okay, so we're going to copy the curve of this. Do you guys see how it looks like we should maybe be going in a straight line? We should not, because it's going to be curved like this graph. So what we do is we draw half of a U shape going up, and we draw half of a U shape going down. So we don't connect those with straight lines because we know that something cubed is not going to give us a straight line. Y equals mx plus b gives us straight lines. This does not. Okay, so even though the 3 points could have been connected using a straight line, we don't do that because that would be wrong. What are the transformations? What are the transformations for this graph? Vertical compression, but not left one, right one, and up 5. Okay, we have to find the domain and the range. What do you guys think the domain is? Yeah, negative infinity to positive infinity, because if we look on the left side, we have an arrow. If we look on the right side, we have an arrow, and nothing skipped. This whole graph is, all the x values are there. So we have negative infinity to positive infinity. What about the range? Yeah, same thing. Goes down forever, goes up forever. So these graphs are kind of nice for domain and range because you don't really have to think about it. If we put a stick figure on the left side of the graph, what's he doing? He's increasing. And then what is he still doing? Increasing. He increases the whole way. He doesn't increase at the same speed the whole way, but he increases the whole way. What is the x coordinate of a left arrow? What is the x coordinate of a right arrow? Infinity. Okay, so for increasing interval, we're going to write negative infinity to positive infinity. For decreasing interval, we're going to write none. There was no part where he went down. Okay, what else do we find? Max and min, okay. Is there a little mountaintop or a little valley in there? Nope, so we're going to say none, none. Okay, what else do we find? X and Y intercepts. So this one really does have an X intercept. And so on my calculator, I do second trace. And which one do I use? Number 2. We're looking for the 0 of the graph. We use number 2. Okay, so what do I do now? Yeah, so the x-intercept is right here. I need to bring the cursor to the left of that. So my cursor's on the left, I press enter, and then I go to the right. My cursor's on the right, I press enter. The guess is always stupid, so I always press enter one more time. Negative 1.154. So at this point, I should be able to give you any equation, and you should be able to find the x-intercept. Could we do that? Because we got a calculator. All we have to do is we have to know how to scroll left and scroll right. Okay. How do I find the y-intercept? Second trace 1, plug in 0. And so what's the y-intercept? 4.5. Okay, what else are we checking for? End behavior. So I'm going to say as x goes to the left, so what do we see about the arrow on the left? Does it go up or does it go down? On the left. It goes down. So as we look to the left, the y value goes, so the arrow goes down, so what number is that? Negative infinity. Okay. Oh, thank you. Oh, you're good. As x goes to the right, which way does the arrow go? The arrow goes up. So y goes to positive infinity. Okay, and the last thing we check starts with a C. continuity. So if I put my finger on it and I trace it, do I ever have to pick up my finger? Nope, so this is continuous. All right, last one. I'm gonna flip the page over. So go ahead and type the 4, and then to get that little cube root in there, you hit the math button, and you go down to option number 4, right? So 4, and then we've got the cube root of x minus 6 with a plus 2 on the end. Again, this one does not have a vertex. We call it a locator point. What's the locator point for this one? 6, 2. Okay, remind me again why I care what the locator point is. Why, for when I draw it on my paper, does the locator point matter? Yeah, it helps you know where to look on the table. So if you don't know where the locator point is, then on the table it's kind of hard to figure out where you should start looking. Do you guys see how it looks like there's a gap in the middle? There is not. Your calculator, see how your calculator has like the little squares? When it does curves, it has like a little square next to a little square next to a little square. You guys see that? Your calculator has a hard time drawing lines that are very, very, very steep. Like if I tried to get my calculator to graph something that had a slope of 100, it went up 100 over 1, your calculator would have a hard time with that because that's almost a straight up and down line. And your calculator says straight up and down lines are not functions, and your calculator doesn't graph anything that's not a function. So your calculator makes it look like there's a gap there because it goes almost perfectly straight up and down, and that doesn't mean there is a gap there, it just means your calculator's having a hard time with it. Okay, so when you draw this on your paper, do not draw a gap. You fill that in, okay? So we're going to do second graph. We've got that point at 6, 2. And so on my window here, I'm going to look for 6, 2. That's right in the middle. And then the points around that are going to be the rest of what I'm going to draw. So I've got 5, negative 2. And I've got 7, 6. And then I'm going to see if there's any other points that I can graph that aren't decimals. Negative 2, negative 6. And then 7, 6 I already had. And the other ones are too big. 14, 10 would be the other one. Okay, so if you kind of look at this one, it's like a U shape to one side and a U shape to the other side. So I'm going to start at the middle, and then I'm going to draw a U shape. And this one has a stretch of 4, which is why it's not going to be as shallow curved as this one, because it's being very stretched out. And then here's our other U shape right here. It's just kind of like a sideways U shape. So there's no gap in the middle. The calculator just has a hard time graphing it. Okay, so what are the transformations? We can go ahead and write those. Okay, vertical stretch of 4. Right, 6 up 2. Okay, we want to find the domain and the range. Domain is left and right. Negative infinity to positive. What about up and down? Yep. Okay. Increasing and decreasing. So we'll go ahead and draw our little stick figure. And what is our stick figure doing? Increasing, and then he increases super steep, and then he keeps increasing. But he's increasing the whole time, always going up. So what is the x value right here? Okay. What is the x value over here? Okay. And so we say he's increasing negative infinity to positive infinity, and for decreasing we put none. Okay. What about max and min? Yeah, none and none. Okay, what else do we find? Okay, x-intercept, y-intercept. So I've got second trace, option number 2 to get the x-intercept. So I've got my left bound and my right bound. So 5.875. And then my y-intercept is negative 5.268. What else do we want to find? And behavior. So we're going to say as x goes to the left forever, what do we see about that left arrow? Is it going up or is it going down? It's going down. So as x goes left forever, y goes negative infinity. It goes down. As x goes right forever, y goes up. It goes to positive infinity. Okay. And then what do we know about the continuity? It's continuous. I can trace the whole graph with my finger. Okay. So when we look at this assignment, it says to write the name of the parent function. And the names of the parent functions, we have absolute value graphs. Y equals the absolute value of x is an absolute value graph. If we have y equals x squared, what's the name of that kind of graph? Starts with a Q. Quadratic. If we have y equals the square root of x, what's that called? What's it called? Square root. What an interesting name. All right. If we have y equals x cubed, what do we call that graph? Cubic. And then if we have y equals the cube root, what do we call that graph? Cube root. Okay. So when they say to write the name of the parent function, that's what they're asking. Okay. The name of a parent function and the transformations are different things. So when I see that little exponent of 2 there, that little exponent of 2 is not a transformation. It's what tells me what the parent graph is. It tells me that when I graph this, it's going to be a U-shaped graph. Does that make sense? When I see this little 3 here, it doesn't tell me a transformation. What does it tell me? It's going to be a cubed graph, a cubic graph, and it's going to have that weird like curve to it. They call that an S-curve. When I see this little squared right here, what does that tell me? It's going to be a quadratic. How is this one in the right form? No. Do we remember how to convert into vertex form? Yes. Okay, let's do that real quick, and then I'll let you guys start working if you've already done your test. All right, so what do I do first?
Add the 4.
Add the 4. Okay, so I have y plus 4 equals negative x squared plus 6x. Yeah. Yes. So Charlie just said, do we have to take out the negative? What's the answer? Yes. Okay, so I'm keeping the y plus 4. I am taking out the negative, and that leaves me with x squared minus 6x plus blank. And somebody other than Kaylee tell me how Kaylee got 9. So negative 6 divided by 2 is negative 3. And not square root, square. I need to square the negative 3. Negative 3 squared is 9. And so 9 is the number that completes the square. But did we actually add 9? We did not. We actually subtracted 9, right? So since I subtracted 9 on the right side, I'm going to subtract the 9 on the left side. And so now I don't have y plus 4. What do I have now? Y minus 5 equals negative of something squared of x minus 3. Perfect, right? Because that number, whatever we got when we divided by 2, that's what goes in parentheses. And then we add the 5 over. And then, now that all of that work is done, now you can say the transformations. Reflected over the x-axis, right 3, up 5, and what is the parent function? The parent function, it's got a squared quadratic, so the parent function is a quadratic. Okay, so for this one we would say quadratic, reflect over x, right 3, up 5. All right. So for the people who completely did their test yesterday, this is what you're going to be working on. Okay? So anyone who's finished, you work on this assignment. I will get the answer key out so you can check it.